As a perennial crop, vines act as carbon sinks. And this positive impact is an important component of the carbon footprint of viticulture operations. And as such, it should be taken into account into any GHG inventory, so greenhouse gas inventory, any life cycle analysis, any carbon footprinting exercise, or also any ESG report. Especially if you would like to take into account the impact of changes that were made in the past or that are going to be implemented in the agricultural practices on the vineyards, for instance. But the question is, how can you measure it? Actually, the current traditional methodologies or methods to measure it are all based on soil sampling. But soil samples, they have huge limitations. So as you know, it's expensive to plant soil samples, especially if your vineyard is spread in many areas, especially if your fields can have also different natures of soil. Sometimes you have some fields that on the one hand they are like sandy, on the other hand it's another type of soil, so it is not even relevant to have just one soil sample for each field. You also cannot plant soil samples anytime in the year. You can't do it when it's too wet, you can't do it when it's too dry, you can't do it when you're harvesting. So you can't have a true monthly vision on what's happening on a carbon standpoint on your field. These are some limitations, but the biggest limitation of soil sample is that it really only gives you information about the soil, not about the ecosystem health as its whole. And the ecosystem, in that case, I mean not only the soil, but also the roots, also the visible part of the plant, and so on. So at CarbonSpace, we have developed a proprietary technology that was 5 years ago, which is scientifically recognized, which is fully compliant with the greenhouse gas protocol, as it has been verified against the ISO 14064 standard. So what we do is that we use artificial intelligence, so based on well, satellite data, of course, but also meteorological data and data coming from ground stations to estimate net ecosystem exchanges. This word, this expression may look complex, but it is actually a very simple metric. Net ecosystem exchanges is the difference between the emissions and the sequestrations that are happening for any ecosystem, so for the vineyard in this case. And in other words, it's also the difference between photosynthesis and respirations. So these are the two major fluxes that you can see on the screen, in green and in orange, and that are happening between the atmosphere and the ecosystem. As you can see also on the screen, the big advantage of net ecosystem exchange is that it takes into account all the major carbon pools of the ecosystem. So not only the soil, but also the above ground biomass, the below ground biomass, well, the soil of course, and also the dead organic matters. So as a result of this, you get one figure expressed in tons of CO2 that gives you an idea on how healthy your ecosystem is based on how much carbon is able to absorb. So the healthier the vineyard, the more carbon it absorbs. And so we can calculate that on a monthly basis at the field level, of course. And we can also do that for the 24 last years. So it's also very useful if you had no time to make soil samples before you started some tests, for instance, and you would like to compare the situation with what was happening before. So how does it work more precisely? So what we did at the beginning is that we collected data from a number of flux stations. Flux stations, these are stations just like the ones that you can see on my screen, big towers with chambers at different heights that are measuring the atmospheric composition across a large number of ecosystems and agroclimatic conditions. So you have some in the vineyards, you have some in the croplands, in forests, and so on. We use this data as well as meteorological data and data from the satellites to train our models and create our proprietary technology to make it an easily scalable tool, allowing anyone to remotely monitor the carbon performance of a vineyard. And so how can we be sure that this is working also for vineyards? Because as well, Michel said previously, well, how can we change something that we can't measure? That's a question that we are also trying to give an answer to. So to give an example, it seems a bit technical, we'll try to explain it in simple words. We have a cross-validation process. So I mentioned the towers before, but what matters is that we need to be able to say that our methods, so our predictive models dedicated to vineyards, are also working in areas in which there are no towers. Because the cost of a tower is impressive. It costs like about 60,000 euros. Not everyone can afford to do that. That's why usually they are bought by research institutes, university, or wine institutes, for the sake of understanding the carbon dynamics of the vineyards. In our case, so we had a cross-validation process to make sure that it works even in the absence of a tower. So what you see on my screen is an example of a validation that we made in Italy. So we first analyzed a vineyard on which there is a tower, but we are not using this tower in our algorithms at all. So we excluded voluntarily a number of towers in order to be able to use them at a later stage for validation, for checking our data. So what you can see in purple on the chart here is the CarbonSpace prediction, while the big blue area refers to the mean standard deviation. So to say it in other words, it means the highest and the lowest value that we could in theory expect from a vineyard with these qualities, so located in this region, so located in Italy for this specific months, and so on. So first thing is that our predictions were also included within the standard deviation, so which meant that, well, our data were logical. And then we compared our data with the true measurements from the tower, which are the ones that you can see in red. And so we could see that it's also very relevant. Well, we will just say a small gap in May, which we can explain by the lack of data above this specific plot in May. It was cloudy in Italy this month, and so we are lacking satellite imagery. So that's a previous version of our technology. So now we have a new radar specialist based in Athens working on improving our fonts of data even when there are clouds. And also we added a number of meteorological fonts to make sure that the both tracks are parallel or are in the same way. So once a model is validated, we can apply it to other vineyards in which there are, and there won't be any tower actually, so just like the one that you can see in green, which is another vineyard in Italy, located very close to the one that had the tower. And what's interesting is that this one has no issue, had no issue in May, so the track is really following the red one. So it shows that, yeah, it's working for that as well. Now I would like to share a few examples on how the technology can be applied to vineyards, or what are a few examples of use cases. So what you can see on my screen is our platform. So like any wine grower can have access to our platform, in which the maps are being uploaded, and for each plot you can see precisely for each year, for each month, if the plot has been emitting carbon or taking carbon. So what I didn't see before about net ecosystem exchanges is that it can, as it's a difference, it can be positive or it can be negative. It is positive if you have more emissions than uptakes. In that case, it tells you the amount in tons of CO2 that were emitted. While if it's negative, it shows the amount of CO2 that was removed from the atmosphere. So it's a bit small, but what you can see on the upper chart is that you have small thin red bars, which correspond to small emissions, and you have big green bars, which correspond to high uptakes. There are two major use cases for using our technology. First of all, CarbonSpace can be used for regular monitoring at field level, and also to generate claims based on the changes in agricultural practices that were implemented, for instance. I will share 3 examples. The first example is a vineyard located in Italy, in the Veneto area, close to Verona. So they implemented a number of new practices, like cover cropping, reduced tillage, also improved the crop residue management with vine leaves shed in autumn and annual vine pruning residues in winter. And they also started a gradual reduction in agrochemical usage. They have a total of 1,030 hectares and several types of grapes, so among which Corvina, Corvinone, Rondinella, Garganega, Chardonnay. So you can see on the right chart exactly what I told before, that the carbon, the uptakes corresponding to this area have been gradually improving since the beginning of the changes. So the regular increase of the uptakes, I can also tell it in figures, so it started from 3 tons of CO2 per hectare per year in 2003, and it reached 16 tons of CO2 per hectare per year, despite, of course, some variations in the climate that can also affect the performance of a specific year if there is a drought or a lack of rain or a disease or whatever. While on the left side, what you can see is the comparison of the years that are following the implementation of these practices versus the average of the 10 years before. As we have the historical data, we are able to calculate the carbon historical baseline. So to tell you, on average, if we take into account the 10 years before, that's what we would have expected. And so when it's green, it shows that the performance, even from the first year of the implementation of these practices, was better with respect to the 10 years before. And this vineyard actually incorporating the true carbon sequestration of their vineyards was able to claim a 100% carbon neutrality, of course only at the vineyard level, so not taking into account the bottle and other external operations, but it still considers it an important marketing argument, especially for scaling as export strategy across the Atlantic and especially in Canada. I have 2 very different examples from 2 different areas. So the first one in Mendoza in Argentina, a vineyard with semi-arid climate, sandy loam and low organic matter content, which was performing very poorly. Actually, it was even emitting carbon, which should not be the case. So they decided to act to enhance CO2 sequestration. The primary goal was, of course, to improve soil health, but they improved more than soil health because it was reflected in the whole ecosystem health. So what they did is they implemented cover cropping between the wine rows during the off seasons, mostly legumes and grasses, and also organic amendments. And so while, as you can see in red, in 2015, the vineyard was a net carbon emitter, In 2016, already, it started slightly uptaking. So after 5 years, we also can't say that a huge amount of tons of CO2 are being uptaken every year, but still the annual carbon sequestration reached 1.6 tons of CO2 per hectare per year, which is good compared to the previous situation. And we had a similar project with a different ground, well, different terroir in Aquitaine, in France, in which a different cover crop was added. So in that case, the vine grower added mixed cover crops like rye, veg, and grass, and also organic amendments, and measured the CO2 impact across 6 years. And despite the fact that it's not in the same area, it's very similar in terms of results to the Argentinian examples. And so, yeah, also after 1 year, we could see a progression. It seems to us that after 5 years, maybe we have reached like the maximum amount in terms of progression, but we can't still be sure. And we need to continue the monitoring to make sure that we cannot improve it more. And the second big use case for using CarbonSpace is for a scientific project. Every terroir, every appellation has its specificities, and to some extent we could also say that each vineyard in itself is unique. That says it all. That says also that it's nonsense to use market averages, country averages, when it's about calculating a carbon footprint. Why would you compare yourself with another vineyard on the other side of the country just because the literature is missing, for instance? So a number of national associations, regional associations, they want to have more information about their own appellation. But of course, it's also not doable to plan soil samples and field visit on each field, because it's time consuming, because it's expensive, because wine growers have also no time to dedicate to such questions. They have so much to do already in their everyday life. But it's also important because, well, by doing that, you can gather an important fount of information that can help also the other vine growers from the same region or the same appellation improve their practices. So it's also the best way to share the best practices. And if you manage on a country level or a regional level to identify the best and poorest carbon performing vineyards, you can also understand which practices they are using that are working here, and you can deploy them potentially on the rest of the country. So to mention one of these projects, we started a 5-year project with the Burgundy Wine Board, Bureau Interprofessionnel des Vins de Bourgogne in France, in the framework of the MOCA project. So it's MOCA for mitigating climate change by managing organic matter. So a project led by the Burgundy Wine Board, also by the Vinipôle Sud Bourgogne, the University of Burgundy, IAD Dijon, the Chambers of Agriculture of Côte d'Or, Saône-et-Loire, and Yonne, and 94 vine growers. I need to mention them in any presentation that I do because they are the ones that are founding the project. And it's a huge project. So it aims, first of all, to help the wine growers better understand and manage carbon storage in the soil to reduce GHG emissions and also increase soil health and resilience, especially if in the future some chemicals are not allowed anymore. So to find some soft alternative that will be ideally even more efficient in terms of health and efficiency. So in that case, it started with a survey of 30 vine growers on their management of organic matters in order to identify which practices were used. Like, for instance, in terms of vine shoot management, so if they were burnt or crushed. So I know that in Greece, it's not possible to burn them anymore. Also in Italy, it's not possible anymore. In France, it's still possible. So the difference still exists. Also different interpretation of grassing, implementation of cover crops, permanent, semi-permanent, on all rows, between the rows, off-season, the application of organic or mineral fertilizer, the present or the absence of amendments. So based on that, we created a sample of these 94 vineyards. We are now at the stage in which we have finalized our calculations. And the ultimate step is that a flux tower will be inaugurated actually on July 11th, so it's coming soon in some 10 days. That will help improving even more our data. We estimate the improvement of about 1 to 2% improvement versus what we do now. So that we saw, that's what we saw in the previous project. And the missing part is to analyze the data. So I wish I could have shared with you some insight already, but it's such a deep research that it will take time for us to find the correlation between the practices and the impact of these practices on the capacity of the vineyards to absorb carbon. I would like to finish with two sentences. The first one from Héloïse Mahé, Vice Technical Director at the Burgundy Wine Board. So she just left actually, but she started the project. And so actually why she wanted to start the project is that she really wants to provide wine growers with the keys that they need to manage to optimize carbon storage in their soil. So she really felt like that something was missing in this area. And also to finish with something positive, what we want to do at CarbonSpace, what we hope to do and what we want to do with you. And we want to help wine growers, also wine federations actually, and the world in general. We feel that we need to recognize responsible wine growers, and it's not the case, unfortunately, in the everyday life because of the packaging, because not everything is visible, because the impact of the changes in practices is not visible, and yeah, maybe people are focusing on the bottle and so on, but what's happening on the ground is important too, and well, someone needs to say that vineyards are at some point uptaking carbon, and that's also something positive that everyone should know. So thank you very much for your attention. In case you would have a question at the later stage, feel free also to reach out directly to me.